Now, something we know as well as our middle name from this course already is the fact that we are going to design the overall network infrastructure utilizing a modular approach. Well, it's time now for us to really delve into the design of one of those important modules, and we called it the campus module. Let's really examine the ins and outs of designing that important module now. So, what specifically will we achieve in this section? Well, first of all, let's talk about some overall design factors that we have when we are talking about the campus. We'll talk about things like how the particular network applications we're going to use could influence our design, or maybe even environmental considerations like geography. And then we'll do something that you're probably expecting us to do. You know that there's the important access layer of the campus, the distribution layer of the campus, and the core layer of the campus. So we'll go ahead and we'll specify the particular design ingredients that we would find typically in each of these layers of the enterprise campus. Now, before we delve into the detailed design of those detailed layers, let's just go ahead and talk about some overall design factors for the campus. The importance, obviously, of what network applications we're going to be running cannot be emphasized enough, so we'll elaborate on that a bit. Also, we need to talk about how the infrastructure device characteristics is going to drive our overall design. And finally, we'll talk about environmental characteristics and how they can impact the design of our campus infrastructure. Now, early on in one of our CBT nuggets about really preparing for the network design, we talked about the importance of looking at the particular network applications that an organization was going to run. Sure enough, when we were talking about getting ready for the enterprise campus design, we want to revisit this subject of the types of network applications we're going to run. One of the things that you can do to really assist you is break down the network application types of your campus into 4 general categories. There's point-to-point type of applications. A great example of this would be a voice over IP implementation. Then there's client to local server applications. These are client pieces that are going to be accessing a server that is local to that particular LAN segment. Then there's client to data center. By the way, in your exam environment, they might use the old terminology here of server farm. But notice I'm using the more modern terminology of data center. And then finally, there's the application types of client to enterprise edge. These days, it seems like these apps might make up 80% or more of your organization's network applications. This, of course, is an application that needs internet connectivity in order to function, and we access that by using the Enterprise Edge module. So, taking your network applications of the campus and breaking them down into these 4 different potential categories can really help you when it comes to designing your infrastructure, and the reason why we're going to talk about next. You see, the reason why we want to go through that careful characterization of the network apps into those various categories is that the network apps are going to have different requirements. For instance, some of your network applications, like a client to local server type of application, can take a wider variety of connection types oftentimes because of the low latency due to the overall distance between those 2 entities. So for instance, we might have wireless as a valid option there. The overall amount of throughput that you need might be impacted by the network app requirement. Take the case of the point-to-point app voice over IP. We know the throughput required by voice over IP is actually very slight in typical environments, but of course the quality of service requirements are intense. Also, categorizing your network applications can help you with the high availability factor. For each application, we have to look at just how much we would invest in manpower and in equipment and good old-fashioned dollars to make sure that the solution or the network application is always available. And then finally, of course, overall total cost. That's right, the various network applications are going to have different requirements for overall total cost to implement. Now, another major area of design consideration when it comes to the enterprise campus is the overall infrastructure device characteristics. For example, we might choose a layer 2 switch for the access layer, and then we might choose a layer 3 switch for the distribution layer. So when we're looking at the differences between these devices for a particular aspect of design, we really need to consider the operational characteristics of the different devices. For instance, let's say we're talking about QoS. Maybe we have a voice over IP application that we need to support, so obviously QoS is going to be a major concern for us in this infrastructure. At the layer 2 device, we might discover that, yeah, okay, good news. We can go ahead and mark traffic. We can categorize traffic and we can mark traffic there at layer 2, but we can really do little else with the traffic. And then we discover, okay, at our layer 3 switch, we're going to be able to do congestion avoidance and congestion management based on those markings. So notice the different devices are going to have dramatically different capabilities. So we need to look at our choice of infrastructure device because that is definitely going to impact how we design the overall campus network. Now, the last category of overall design factors for the enterprise campus would be environmental. Take, for instance, geography. Yeah, we typically recognize designs that are going to be intra-building as opposed to designs that are inter-building, as opposed to designs that are going to incorporate some remote buildings. We know the particular term for that type of an environment is a metropolitan area network. But think about it. Whether you're dealing with inside buildings or between buildings is definitely going to influence the elements of your design. A great example would be inside a building, we're obviously going to often have copper for the media connectivity or wireless for the media connectivity because that's going to work so well. When you start talking about interbuilding and remote buildings, we often are going to get involved with optical fiber connections in order to make the campus LAN infrastructure work properly. So, when it comes to environmental factors, probably the biggest one that we're going to combat is overall geography. Now, when it comes to designing for the access layer, you want to give a lot of consideration to exactly how you're going to implement your VLANs. The most common approach today is to go ahead and implement them on a local VLAN approach. So you'd have like first floor west VLAN, first floor east VLAN. And notice this is a dramatic deviance from, let's say, the end-to-end VLAN approach, where we're going to say, okay, if you're in sales, you're going to be in the sales VLAN no matter where you exist in the infrastructure. Something else, and I want to talk about this in much more detail next, is spanning tree protocol. Specifically, we want to make sure we're doing as many best practices as possible with spanning tree protocol, utilizing something called the spanning tree protocol toolkit. And I'll talk about that toolkit with you in more detail next in this nugget. But keep in mind, these days, we want to make sure we are running multiple spanning tree protocol, most likely, in conjunction with rapid spanning tree protocol. This is 802.1s, and this is 802.1w. So we want to make sure we are taking advantage of the latest, greatest spanning tree technologies and that spanning tree protocol toolkit that I'll elaborate on here shortly. When it comes to your trunk links, we want to make sure we form them in a best practice type of configuration, and that these days means no longer relying on the dynamic trunk protocol. The specific command is switch port no negotiate. Yeah, abbreviated just like this at the command line, and this will make sure that dynamic trunk protocol is not used to form the trunk links in your infrastructure. Decide on whether you're going to use the port aggregation protocol from Cisco or the link aggregation and control protocol, the open standard, to form, of course, your Ether channels, right? And these will go ahead and trick Spanning Tree Protocol into thinking that your links are just one link between your access layer devices, and this will result in Spanning Tree Protocol not blocking a functional link on you. And then finally, are you going to try and eliminate Spanning Tree Protocol entirely from the equation by moving routing out to your access layer? Yeah, think about it. If we have all layer 3 links between our layers, then we can eliminate the need for Spanning Tree Protocol entirely. But in most environments at the access layer, we are going to have layer 2 technologies that require Spanning Tree Protocol. So as promised, let me go ahead and elaborate for you on that Spanning Tree Protocol toolkit. Now, if you are talking about classic Spanning Tree Protocol, that's 802.1d. There are three particular technologies that you are going to utilize from the Spanning Tree Protocol toolkit, most likely. The first is Backbone Fast. And Backbone Fast seeks to improve convergence when there is an indirect, a non-directly connected failure in the Spanning Tree infrastructure. Something else that you're going to take advantage of is Uplink Fast. Uplink Fast is a Cisco invention for improving convergence when there is a failure of a directly connected device. We use this specifically at the access layer of our infrastructure. Backbone Fast is used everywhere. So let's go ahead now and talk about another one, and that is Port Fast. And with Port Fast, this is going to actually live on in an 802.1 S/W type of environment as well. So while we only use Backbone Fast and Uplink Fast with classic Spanning Tree Protocol, Port Fast is the first of these technologies that lives on in the new Spanning Tree environments. Port Fast is used on our access ports. That's right, and it says, look, we will not plug in any switch or hub or anything else that can cause a loop on that particular port. This allows the port to go immediately to a forwarding state, and also when the workstation or the server is powered off, there won't be an issue with topology change notifications being sent. Now, another Spanning Tree Protocol toolkit technology that goes hand in hand with Port Fast is BPDU Guard. And BPDU Guard is used in Port Fast environments and says, look, if someone does plug in a switch to the Port Fast port, I'm going to go ahead and error disable that port, since we don't want the chance for routing loops, and someone has really gone against our design here, and they're plugging in something that could cause a loop onto that port. Two other great Spanning Tree Protocol toolkit tools I want you to be aware of are Root Guard and Loop Guard. Now, what Root Guard does is it says, look, in our particular topology, we have a root of the Spanning Tree Protocol, and we do not want some switch, let's say switch 2, to come in and try and take over as the root. So what Root Guard will do is if it sees what are called superior BPDUs coming in on a link from some other rogue device, it will error disable. Actually, it makes the port in what's called an inconsistent state, essentially error disabling it. And this says, look, there's a problem on this port. Someone's trying to take over as the root device over that particular port. Now, what Loop Guard does is something very interesting. Let's say we have switch 1, and then we have our switch 2, and let's say there is a blocking port on these two devices on this link. So here we can see on switch 1 we have a blocking port, and then we can see the switch port on switch 2 is forwarding. Let's say that BPDUs stop showing up. We know in a typical spanning tree environment, this port will transition from the blocking state to the forwarding state. But not if we've configured LoopGuard. LoopGuard says, look, we are not going to transition to the forwarding state. We're going to go into a loop inconsistent state, and we're going to notify the administrator that something has gone wrong. So notice it's a very conservative approach, and it could result in a lack of communications through your access plane. But understand that we're just being conservative here, right? We're not going to take a link to the forwarding state for fear that that might introduce a loop into our particular topology. So backbone fast, uplink fast, port fast, BPDU guard, root guard, loop guard, all of these are great spanning tree protocol tools that you can design into network infrastructures to either enhance spanning tree protocol's operation or to add security to it. Now, what about particular technologies at the distribution layer? Well, one of the things that we tend to have to worry about first at the distribution layer is if the VLANs are going to be extending into the distribution layer, we have to make sure that they are fully known among all of our devices at that distribution layer. So let me sketch this out. Here we have an access layer device, an access layer device, an access layer device, and these devices, let's say, connect up to 2 distribution layer devices. So we have connectivity that looks like this, right? We have these devices that are connecting out to the distribution layer devices. And notice we add redundancy and we build this connectivity in what we call triangles. Yeah, notice redundant triangles are what we tend to build when we are talking about the access layer to distribution layer connectivity. Now, we need to make sure that the VLANs that we are utilizing, let's say VLAN 100s over here, VLAN 200s over here, we need to make sure that these VLANs are known between the distribution layer devices. We typically want to go ahead and link these devices directly, these multiple distribution layer devices, and we want to make sure we propagate and properly populate this VLAN information across these distribution layer devices. Now, something else that we consider is, of course, layer 3 routing existing in the distribution layer. Now, the minute you start talking about layer 3 routing, you should immediately think of high availability solutions, right? And the high availability solutions that we commonly have as options today are as follows. There's the hot standby router protocol. This is a first generation invention from Cisco Systems. This is not an open standard. This is a proprietary solution from Cisco in order to have multiple default gateways be presented to the devices of, let's say, the access layer. So we can have multiple devices like device number 1 and device number 2 presenting a default gateway address to the various access layer devices. If one of the distribution layer devices is unreachable, the other can act as the default gateway. How awesome! Now, another technology that exists here is the Virtual Router Redundancy Protocol, or VRRP. This is identical for the most part to HSRP, but it is an open IETF standard. And then finally, Cisco has invented a latest generation technology called GLBP. This is the Gateway Load Balancing Protocol. It seeks to do what HSRP and VRRP do, but it will also, as its name implies, allow automatic, intelligent load balancing between the multiple redundant default gateways that are in your design. So this is the latest, greatest technology that you should consider implementing from Cisco Systems. And that brings us to the core layer, where our design concerns center around three things. Those three things: speed, speed, and more speed. So we are looking to eliminate as much as possible concerns and mechanisms involving security. Even something involving like QoS, we attempt to minimize by over provisioning the bandwidth in the network infrastructure. Now, something that's pretty interesting about the core layer is the debate on whether or not you'll even design a separate core. You see, what ends up happening in a lot of organizations is that they'll have this distribution layer which leads out to access layers, okay? And what they'll do is they'll just go ahead and connect the distribution layer blocks. Okay, they'll connect these in triangles, and they'll go ahead and have this distribution layer function as well as the core. This is a design called the collapsed core, and I want you to be aware of it. Okay, so in some organizations, they'll say, you know what, we're not going to design a separate core infrastructure. Instead, we're going to collapse the core into the distribution layer, and that's going to be how we implement that core layer in all actuality. So in this CBT nugget, we talked about some overall design factors that would be important when designing the enterprise campus. Factors that centered around the particular network application characteristics we have, particular infrastructure device characteristics, and also environmental characteristics like overall geography. Then what we did is we launched on a discussion of the access layer design components, the distribution layer design components, and the core layer design components. In the case of the core layer, we discovered something very interesting that said we might not even design one. We might collapse the core layer into the distribution layer in a collapsed core design. Well, I hope this has been informative for you, and I'd like to thank you for viewing.